How this app works, a step-by-step guide. Capturing faces asterisk. Each time you click Capture Face, or upload an image, the app takes a snapshot from your camera or file, converts it to grayscale, and adds it to your collection. You need at least 2 faces to get started, but the more you add, especially if they are well lit, centered, and a bit different from each other, the better the results will be. Alignment matters asterisk. For best results, try to keep each face in roughly the same position, size, and orientation in the frame. This means centering the face, facing forward, and keeping it about the same scale every time. Good alignment helps the app compare features accurately and makes the eigenfaces much clearer. What happens after capture? Once you have at least 2 faces, the app calculates the mean face, the average of all your captures, and then finds the main ways your faces differ from each other. These differences are called eigenfaces. They are like the basic building blocks or patterns that make each face unique in your set. Adjusting the weights asterisk. After capturing, you'll see sliders appear. Each slider controls the weight of a different eigenface. By moving these sliders, you mix and match the patterns to create new faces or reconstruct the ones you captured. It's like adjusting the ingredients in a recipe. Changing the weights lets you see how each pattern affects the final face image in real time. You can also use the play button to animate a slider and watch how the reconstruction changes. How many images do you need? You can start with just 2 faces, but that's very limited. For more realistic and interesting results, try to capture 5 to 10 different faces. The more variety and quality you have, the better the app can learn and reconstruct faces. What determines the quality of an eigenface? The quality and clarity of each eigenface depends on 2 main things. Eigenvalue, variance explained eigenfaces with higher eigenvalues capture more of the important differences in your dataset and tend to look clearer and more meaningful. Input data quality asterisk well-aligned, well-lit, and diverse faces produce clearer, more informative eigenfaces. If your faces are poorly aligned or all look very similar, the eigenfaces may appear noisy or less useful. How do the weights work? Each slider you see after capturing faces controls the weight of a different eigenface. When you move a slider, you're deciding how much of that particular facial pattern, eigenface, to mix into the final image. The weights don't have to add up to any specific value, they can be positive or negative, and each one independently changes the influence of its eigenface. By adjusting them, you can create new faces, exaggerate certain features, or even try to reconstruct one of your original captures. The sliders work together, so changing one can affect the overall look, but you can experiment freely, there's no wrong combination. What happens with expressions or movements? If you capture one image with a neutral expression and another with, say, your eyebrows raised, the app will notice that eyebrow movement is a key difference. When you adjust the weights, especially for the eigenface that represents eyebrow movement, you'll see the reconstructed face smoothly transition between the neutral and raised eyebrow look. So, by moving that slider, you're blending in more or less of the eyebrow raising feature, and the face on the screen will change accordingly, almost like morphing between your different expressions. Why might reconstructions look low-res or less natural? The naturalness and detail of the reconstructed face depend on a few things. The image size you choose, higher is better, but slower, the number and variety of faces you capture, and how well aligned your faces are. With only a few images or low resolution, the results will look blurry or cartoonish. Even with more data, eigenfaces are best at capturing the main patterns, not fine details, so some loss of realism is expected. For best results, use the highest resolution you can, capture more faces, and keep your face centered and consistent in each shot. Why is this useful? This technique is foundational for facial recognition, compression, and understanding how computers can see and analyze faces. It's also a fun way to experiment with the building blocks of human appearance. Have fun exploring. Try capturing faces with different expressions, lighting, or even props to see how the eigenfaces and reconstructions change. The more you experiment, the more you'll see how each slider and captured image shapes the results. Honestly, this app is a fun demo, but it definitely has its limitations. First, the reconstructions can look pretty low-res or cartoonish, especially if you use a small image size or only capture a few faces. It's not going to give you photorealistic results. Eigenfaces are really just capturing the main patterns, not all the fine details that make a face look natural. Another thing is alignment. If your face isn't centered and at the same scale in every capture, the eigenfaces get confused and the results look even less realistic. Lighting and camera quality matter too. Bad lighting or blurry images make the eigenfaces noisy. Plus, with only a couple of images, the app doesn't have enough information to really learn what makes your face unique, so the reconstructions are limited. And, of course, this is all running in your browser, so it's not as powerful or accurate as professional facial recognition systems. So, while it's a cool way to play with the basics of facial recognition, don't expect magic. Think of it as an educational toy that shows you the building blocks, not a tool for perfect face reconstruction. A step-by-step guide. Center your face, look straight at the camera, and keep it about the same scale every time. Good alignment helps the app compare features accurately and makes the eigenfaces much clearer. 3. What happens after capture? Once you have at least 2 faces, the app calculates the mean.
Yeah, also everything we do is eventually available on BioniChaos.com. Go check it out, provide your feedback. We're publishing this one. We had a version of it before, but it didn't work in production. It's only worked locally. So now we will redeploy. Let me know if you have any questions. Okay, just real quick, can you explain something about the animations? So how difficult would it be? How would we go about removing the play button from each, or maybe leaving it? I don't know, what do you reckon? But we need a play button, a general play button for the whole thing.
The play button next to each slider animates that slider, smoothly oscillating its value so you can see how changing a single eigenface weight affects the reconstructed face in real time.
Okay, the problem with that, if you can just do continuous conversational response, is that it's animating each slider. So if I have multiple sliders animated, they're all animated at the same time. Whereas I also want like a demo button that will play continuously, that will just animate one slider at a time. Does it make sense?
Yes, that makes sense. Currently, each play button animates its own slider independently, so you can have multiple sliders animating at once. What you want is a single demo button that, when pressed, will animate one slider at a time, e.g., animate slider 1 for a few seconds, then slider 2, etc., giving a clear, step-by-step demonstration of each eigenface effect. To achieve this, remove or disable the per slider play buttons, optional. Add a single demo button above or below the sliders. When demo is pressed, animate the first slider for a set duration, then move to the next, and the code is now updated. The per slider play buttons are removed, and a single demo, animate each slider button is added. When you click this button, it will animate one slider at a time in sequence, showing the effect of each eigenface weight. Only one slider animates at a time, and you can stop the demo at any point. Let me know if you want further adjustments or styling.
Okay, I like the idea. It works pretty well. It's just that can we do the animation all the way that goes up and down the slider for the whole slider? So it's less abrupt. Maybe you can comment on this first. And that's what happens if you move your head.
Right now, the demo animates each slider for a fixed duration, then abruptly resets it to 0 and jumps to the next slider. This can feel a bit sudden or mechanical. A smoother, more natural effect would be to let each slider animate through a full oscillation.
Okay, can we actually try it out in the code?
The demo animation now animates each slider through a full up and down sine wave cycle, from min to max and back, resulting in a much smoother and less abrupt effect before moving to the next.
Okay, this is much better. Can we also make the animation run continuously without stopping, unless we unless we press the button again or something? Made changes.
Made changes. The demo animation will now loop continuously through all sliders, animating each one in turn, until you press the button again to stop. The animation will not stop automatically at the end, it will keep cycling through all eigenface sliders for as long as you want.
Yeah, it actually works as expected. Okay, we have a thumbnail, we'll publish it, it will appear on the page, somewhere on top of the page. Anything biomedical that is directly biomedical related. Well, magnets, not so much. I mean, we yesterday were doing an MRI simulator. It was actually working pretty well. is already on the site, but you can go check it out yourself. Doing yesterday, again we'll do a demo mode, and we can stop the demo. There's a sound. Yeah, the problem with the sound always in the browser that it needs user interaction before the sound actually working. So you can send your Tesla your magnetic field strength. So you can see the spin is lower or higher depending on your magnetic strength. You can also set the angle, so it'll be rotating faster but at a lower angle, or you can do 100 degrees. Is it 100 degrees? Doesn't look like 100 degrees, but and then we'll generate the, obviously, I don't know if I need to say or not, but it's obviously a synthetic MRI image. I actually had a better version of it, because as you can tell, there's an MRI Sim 3, but there would be also a Sim 2. Yeah, that one wasn't very successful. This will just do the received signal but not reconstruct the image. So probably we can get rid of it. What do you think? Also have MRI Sim. That was the first version. Well, yeah, it didn't work very well. So we'll get rid of it as well, shall we? It will start at demo mode after some time if you are not interacting with the page. I'm always forgetting to mirror the image. Need the footage from the camera mirrored. Yeah, that's what happens when I talk too much. We start losing viewers. Every time if you ask someone in person, what do you prefer, human? Well, I guess, obviously biased, obviously depends who that is. Anyhow, let's stick to the content, to the problems at hand. MRI Sim. We also need a thumbnail for this one. BCA. Yeah, so we're publishing a bunch. Let's see. PCA. Okay, we have an image for it, the thumbnail. That's correct. We had a quantum simulator. Okay, we need another entry based on if your face is stolen. That's probably how it's done. All the source code is will be on the page itself, so it's all JavaScript. Okay, let's actually deploy one at a time, because otherwise it will be a mess. It will be a mess. That's how a mess face looks like. I actually don't exactly know why is it so low, such a low resolution when reconstructing. Okay, the image is not working. What? It's a PNG, not a JPEG. That's the problem with agents. PNG is working. Okay, redeploy. If you have any questions, let me know. Otherwise, we'll start chatting to another robot. Right, okay, so we have the Eigenfaces. Okay, it's pulling the camera up. You can select your image size. You can capture the image and do a demo. Well, you can change those manually or just automate. So automate your face. Automate your face. That's BCA. Hey, can you just quickly overview what is it you're looking at on the screen?
Sure, this page is demonstrating eigenfaces, which are principal components extracted from captured faces. Each eigenface represents a key facial feature variation. You can adjust the weights of these eigenfaces using the sliders to see how they contribute to reconstructing a face. Based on what I see, the page appears to be functioning correctly. The address bar shows the URL as bionichaos.com/PCA, and the content seems to match the description you provided. Hey everyone, if you're watching this live stream on YouTube, I encourage you to check out this page at bionichaos.com/PCA and let us know what you think. Your feedback is valuable to us. Interesting. How about this? Have you ever wondered what makes your face uniquely yours? Or how a computer can recognize your best friend just by looking at their picture? These eigenfaces might just hold the secret. Now that you've captured more faces, the system is recomputing the eigenfaces. As you can see, more eigenfaces have appeared, each representing different facial features. The weights below allow you to adjust how much each of these features contributes to reconstructing a new face. Alright, listen up, budding computer visionaries. This app is like a digital artist studio, but instead of paintbrushes, it uses math to create faces. First, you capture images like you just did. Each new face adds more detail for the app to learn from. Then it extracts eigenfaces. These are like the fundamental building blocks of a face. Think of them as the perfect eyebrows, the ideal nose, or the quintessential jawline. And finally, you get to play around with the sliders and... Hey YouTube fam! If you want to dive deeper into how faces are reconstructed, be sure to visit bionichaos.com/PCA and experiment with the sliders. It's a fun way to explore the magic of eigenfaces. What unique faces can you create? Absolutely. Hey everyone, don't just watch this video, go try it out yourself. Visit bionichaos.com/PCA and become a face reconstruction artist. Imagine what you could create, or even who you could recreate. What do you think is the most important eigenface for a perfect smile?
Okay, we actually forgot a few things, which are kinda important. Okay, we haven't updated the MRI simulator. Updated. Can't believe I'm doing this manually. Why am I doing this manually? Hey, we should have like Python script checking the code. Does it work? Kind of. We haven't looked at it in a while. It's only 190 lines, which is not much considering what it does. Still have like 71 things to fix on this site.